We have tonight our speaker, Hari Subramanya.
Subramonyam.
Yeah. And he's at Stanford in the education school, but he also works in the human-centered AI group too. And he does experiments and he builds things and he tries things with students and is quite broad and writes papers that get published in Chi. So that's also good. And today he's going to be talking about this abstract that you guys have probably all read, and it's going to be kind of talking about how UX is going to be changing in the new world of collaboratively working with AI. But I don't really know what it's going to be about because that's up to him. So without further ado, I think that we should let him tell us about UX and AI boundary, rethinking the two. And so thank you very much for coming. And anything more you want? Oh, after the talk, well, during the talk, do you want us to ask questions during the talk or wait till the end?
I think during the talk is fine. It depends, like, how formal is this usually?
We're not very formal.
Okay, yeah, then during the talk is fine.
But okay, but anyway, we will get messages on chat that we will entertain, but we will also, expect that after the talk, 15-20 minutes of question answering, if he can stand it, is a lot of fun. I think it's some of the most interesting time in the evening for me anyway.
Awesome. Well, thank you so much for the introduction, and thank you for telling them about me. And I'm very excited to be in this space. It's way cooler than a conference room at Stanford. And thank you all for coming at 8:30 in the evening. This is almost my bedtime, but we'll see how this goes. Okay, so a lot of my current work is around AI and education, but the stuff I'm going to be talking about is sort of this overarching question that we've been asking, where when you have two people with different expertise trying to collaborate and build things, being an academic who writes code and software but also has an HCI degree, I can sort of navigate these two roles in my head. But when we think about two people, two different minds collaborating, what happens and how does that sort of evolve and change in the landscape of AI and more recently generative AI. So that's what this talk is about. A lot of it is dissertation work from a couple of years ago. So I just want to acknowledge many of my co-authors and students and collaborators in the work I'll be presenting today. Andrew Koo is supposed to be here, and hopefully he'll show up. He works at Google. Maybe you know him. Yeah. So he's supposed to be here. He's getting. Okay, so let's get started. Over the last 30 or 40 years, we've gotten really good at incorporating human-centered design into software engineering workflows. Oh,
please share on Zoom.
Oh, right.
That was us. No worries.
Share. Yes. Okay, am I shared on Zoom now? Awesome. Okay, take two.
Okay.
Let me minimize my Zoom. Okay, so over the last 30, 40 years, we've gotten really good at incorporating human-centered design into software engineering workflows. This is sort of a flight booking website from many years ago, and then we've gone a long way at producing more streamlined workflows, better looking things like this, cluttered and overwhelming interfaces to something we all want to use. So how did this happen, right? To do this, we sort of set up new sort of roles and expertise. We created this UX designer role, people who are trained at understanding human behavior, interface design, usability engineering and whatnot. And they usually sort of like work with end users and like understand their pains and needs and challenges. And then they come up with like requirements. Okay, this is what we need to build in our software systems. And then they go to engineers and tell them like, hey, this is what people need, build it. And these engineers who are experts at like writing code and building software and databases and whatnot, like they're able to build these things to the specifications. So to make it a little bit more concrete, so let's imagine like, building one of those like flight booking website, right? Like if you were a UX designer, you would first try to understand like, oh, like, how do people book flights? Like, what do they need? Like, do they look for multi-city? What are their challenges? Like, what are their concerns? And like, what is confusing? And based on that, you'll come up with like a bunch of requirements. Like, oh, I want to be able to compare different flights. I want like a streamlined booking workflow. I want to be able to try out like a multi-stop flight or whatnot. And then you're able to, as a designer, like prototype all these different interface alternatives. And today we have like really good tools that would allow you to build like really high polished interface prototypes, which you can then like just go and test with end users without even like, building anything, right? Like you have these high fidelity interactive prototypes that you can make today. And then once you test, you would determine like, okay, this is the sort of design that I think people want, or like this is what my evaluation shows that people want. And at this point, like, you would go to the engineer and then you would say like, hey, build this. And then like the engineers know how to like sort of actually create the build system based on the specifications you give them. In this process, like, the UX engineering sort of like interaction is largely that of coordination and handoff, right? Like, we all want efficiency. So we've built this sort of like systems that are optimized for like, modular design. You have like teams that work independently for the most part. But now imagine you are trying to add some like AI, like predictive feature into this flight booking system, where you want to tell people like when is the best time to book the flight, or like, is now like, is this the best flight, or like things are going to change or whatever, right? So how would you design for something like this, where it's hard for you to like create design specifications for like, this is what people want, because a lot of it is like probabilistic, a lot of it is dynamic. And then on the engineering side, like people can't build things to exact specifications, right? Because they are sort of like taking data and like labeling data and like sort of like, it's again, like very probabilistic, very dynamic. It's hard to build things to specifications. And then you have to think about like explainability and like, how do you want to show these results, and how do you deal with uncertainty and like failures and errors and feedback and learnability and so on. So this model of like designers and engineers sort of like operating in this mode of like coordination and handoff is no longer going to work. So this talk is a little bit about like, how might we support like UX designers and AI engineers who've been like in these conventional traditional user interface paradigms, been operating like independently through these like strict separation of concerns and boundaries. Like what needs to change if we are going to help them collaboratively design human-centered AI from the ground up? So to do this, we first started off with like, companies like Microsoft and Google and Apple. They've been putting out all these design guidelines for human AI design. And I just got a Zoom notification. I don't know what that is. Okay. So we started with these guidelines, and then we collected about 280 of these guidelines, and we started to look at like, what are these guidelines talking about, and like who should be operationalizing these human AI guidelines? Is it the AI engineers? Is it the UX designers? Are they product managers, or some new role, or whatever? So the good news is that these guidelines do touch upon like all of like these different layers of an AI application stack. They talk about like, a human-centered way of thinking about the training data, like a human-centered way of like building these models, thinking about like the assumptions and how you go about like designing these models and APIs. But also then how do you think about like human-centered ways of like crafting like the user interfaces and interactions. So very briefly, like, the data level, like, these guidelines talk about like, oh, we should think about like people's needs, or like how people would make these decisions when we're thinking about the training data, like how do we collect data in like the sort of like responsible, ethical way that is sort of representative and has like diverse data? How do we think about labeling data? How do we think about people's privacy and so on? So like, one of the guidelines is like, oh, we should consider what information would a human need if they had to perform a task. And similarly, at the behavior level, like the AI like model level, there's like, how do you think about like designing these models that sort of like reflects the way in which people make these decisions? How do you think about performance? How do you think about like evaluating these models? How do you think about like learnability and so on? Again, like, as an example, when designing automation, we should consider if a human were to perform a task, what assumptions would they make? Similarly, at the user interface level, like, these guidelines talk about like how do you design like the input output in a way that is sort of like aligned with the kind of things people are comfortable providing, like in what format and how they would want the output. How do you think about explaining like these model predictions to users? How do you think about like users providing feedback when these like models fail or when there's uncertainty? Like how do we deal with these failures and so on? So as an example, again, like, there's this thing of like assess automation versus augmentation in an imperfect algorithm. I mean, an imperfect algorithm can be used not to automate decisions, but rather to generate anchor points to augment and improve human decisions. And across all of these sort of like, layers, we need to think about like the human's task model, or like how people think about performing a task on their own. What is their expectation for like intelligence or augmentation in this task workflow? And what is their interaction model? Is this like in a public space? Is this private? Like, in what context should they be interacting with this sort of like system that you're designing? So we then took these guidelines and then we talked to a bunch of people across like 14 different organizations, large and small like industry organizations. Our participants comprised of software engineers, UX designers, product managers, data scientists, research scientists. We use like convenience or snowball sampling to recruit our participants. And then, we did like qualitative coding to like try and understand like how are these people working together, what are like sources of tension, and like when in organizations where they're successfully operationalizing those guidelines, like, what is happening. So I'm getting like these admit pop-ups. Do I need to do anything about it? Okay, cool. Okay. So just at a very high level, like, this is sort of like an aggregate view of like the organizations and the people that we talk to. Many of these larger organizations do have like core research teams, like you have like core AI research teams, or like, who are trying to do like foundational research. Some of them have like core UX teams as well, but then there's also like these legal teams that work across like, different products, and you have domain experts. And then in some organizations, you do have these like bridge teams where like they take this like core AI research and then they sort of build these showcase or like prototypes to then take to product teams where they can then see if they want to like integrate it into their products. And then you have like product teams, and like each product team may have like a manager, a backend developer, or a front-end developer, UX team roles. And across all of these things, like, they do work with like third-party like AI providers. Like, smaller organizations may not have their own sort of like core AI researchers, so they rely on third-party AI providers. You have these external data annotators. You have like university interns who are there for like 3 to 6 months, and they're building these prototypes. And then you do have like test users. So this is sort of like this high-level view of like these different like entities and roles within like a large AI organization. So what did we find? So as I was sort of like alluding to earlier, one of the biggest challenges is like the separation of concerns, or like this boundary between like design and engineering teams sort of like hinder this like cross-cutting needs of like AI experience design, or more generally like human AI design. And what I mean by that is in sort of like conventional software design and development, the user interface, the GUI, acts as this like natural seam between the designers and engineers to sort of like collaborate. For the most part, like, if you're a UX person, like you wouldn't really go and share all your like low fidelity prototypes and like insights from like user interviews and your evaluation outputs and all of that with engineering teams. And in fact, like, one of our like participants in anyway, they were like, oh, these engineers are like blindsided to sketches and wireframes or any other low fidelity prototype. They only understand high fidelity prototypes, even more so if it's interactive. And similarly, on the engineering side, like, they're not going to come to you and like show you like, the details of like the system architecture or the code or anything like that. So there's this like clear sort of like separation of concerns or like these boundaries between design and engineering teams. But it turns out this approach becomes a little bit problematic when you're trying to operationalize all of those guidelines we talked about a minute ago. So the sort of first challenge we observed is that these design and engineering boundaries sort of like introduce what we're calling knowledge blindness. And what we mean by that is like, in order to be able to like design across the stack and to operationalize like human-centered AI across like data and like AI and UX, designers need to know, at least to some extent, the low-level details about like, what assumptions are being made, how is data being collected, how is data being labeled, but then like they don't have that understanding that would help them sort of like incorporate like human-centered design into these built experiences. And similarly, like engineers don't really get to know about like these user needs and stuff like that, which also introduces problems because like people go and like build these like models that don't really serve, the intended like human-centered purpose, or they're not like aligned with human values and so on. So like one example is like, there was this team that was, they had like AI researchers who were doing some like cool like video processing. And then the UX person talking to us, they were like, oh, they would just go off in like these weird directions, like trying to identify like guns in the video. This had something to do with like law enforcement. And that was not really what they were looking for. But then like that's what the engineering teams were excited about, because like they had some like this, what we're calling end user blindness. And similarly, the sort of like the researcher over here who's like an AI person, he was like, it used to be that UX designers just made like static mocks and there was this like screen to screen flow. But with AI, the probability that end users make it through that path is lower because it's driven by a sequence of machine learning models, and the probability space is much more widely open. So they need to be able to understand the grain of the technology. So when you have these boundary separations, like it sort of like introduces this knowledge blindness, which sort of like prevents you from like operationalizing the guidelines like across the stack. A second issue is like these design engineering boundaries impose what we're calling like premature specifications. So if we sort of follow the conventional UX model where like the UX person like says like, this is what I want you to build, and then they take it to the engineers, and then like it's hard for them, like I said, to like build to these specifications. So there's this thing where like, they would just hand off these design documents to the engineers and say like, implement this. And of course, my reaction was, this is garbage. This does not reflect the appropriate architecture for implementing this. This is not a good reflection of how actual software engineering is going to happen. Similarly, on the flip side, like as I said, you have like these AI engineers who spend like lots and lots of resources, or like rather AI researchers, and they build these like models that actually don't align with users' needs. So there was this like one classification system where like they had a bunch of these labels that they then like, they built this model that can like classify things based on a bunch of labels, and then they took it to the product teams and they're like, figure out how to integrate this. But of course, like, these, they have their own taxonomy, and like it does not like evoke a response to the users, or it does not align with the kind of like labels or things that people are looking for, end users are looking for. And the last thing is like, because of these boundaries, like people don't collaborate as much as they're supposed to. So there's this one person who was like a UX person who really wanted to go and like sit in one of these like data annotation sessions. And they were like, it seemed very odd to me that as designers, we were not invited to this annotation session. So we had to invite ourselves just to talk to the domain experts. For engineers, this approach is more like the machine is going to figure it out. We could be talking about health or elephants in a circus, and it's all the same to them. And on the flip side, like, people like UX and AI people are like incentivized differently. So there were cases where like the AI researchers were trying to get like UX inputs early on, but then like that's not part of like what they're getting paid for. So they're like, if you try to involve them early, then they'll say they're busy doing like X, Y, and Z. So these are some of the issues we observed because of these like separation of concerns and like these boundaries between like UX and engineering team. And as we've seen, like, in like many examples, like you should go look up the AI incident database where like these separations lead to all kinds of sort of issues and potential harms to like end users as well. So there were teams that were also successful at operationalizing these guidelines. And what we saw is that the teams were actually successful. Like they sort of like practiced this notion of leaky abstractions. Like instead of having like these rigid boundaries, like there were like holes along the boundaries in many places where you could then like start to exchange information early on. And having that infrastructure was really helpful in sort of like operationalizing these human AI guidelines. So sort of like what I was trying to say, like, where end users are sharing like some of these like low level insights about like users and prototypes and design and like software, like engineers, AI engineers are sharing some of the low level details on the engineering side as well. And again, like this becomes this like language and common ground and like developing a shared language across like UX and AI. And there was this one person said, like, I prefer to learn their language, at least to some degree. Obviously, I'm not going to get to know it as well as they do, but if I could learn it enough, we can reach some kind of common ground. So they need to learn my language a little bit, but I feel like that's kind of on me. And we've seen this in other cases too, where when you have like teachers or domain experts and engineers, like it's easier for the technical people to learn the domain or like UX language than trying to get them to learn more of the technical language. And that's an open question or problem to be solved. So when you have these leaky abstractions, like one, it obviously sort of like alleviates this notion of like knowledge blindness, which I mentioned earlier. So, in successful companies, like these AI researchers would work with UX people like from the ground up, where the UX folks would make like these design visualizations or making a movie or just a series of mock or building an experiential prototype. Like many of us have seen like, these companies like releasing these like futuristic like experiences. And it's kind of interesting where it's so much easier to build these things today. Like you don't have to spend like weeks like trying to orchestrate and like make this video. You can just take some off the shelf model and try and prototype things and then give this like visiony prototype to people trying to build better models. And similarly, we had like in successful teams, you had like these engineers who would like, okay, I want to build this model, but then like they would make these prototypes and then hand it off to the designers and say like, go play with this for a few days and tell me what's working, what's not working. And that was like incredibly helpful in sort of like bridging these knowledge barriers. And again, like these leaky abstractions promote collaboration. There were cases where like, these UX people would like create some interface prototypes and take it to the data scientist or the AI person, and they would like write down like what's going on under the hood and like how are these like predictions being made and so on. And that was really helpful. And similarly, like UX people would share like storyboards and stuff with, especially I think this was in the case of like designing like a conversational interface. So instead of giving like a long dialogue flow diagram, like they would give like vignettes of like, if this, in the situation, if this happens, like this is how the system should respond. And then like the AI engineers found the storyboards like incredibly helpful in thinking about like how to sort of model the conversational interfaces, models. And also evaluation is a big thing, right? Like a lot of times when a UX person like takes some of these like capabilities and like builds stuff and like evaluates at people and brings back results to engineers, like they don't believe it. They go like, you did something wrong. So the way to solve this was like, we found that UX people would just invite the AI engineers to come and sit in the UX evaluation sessions, or other times like, especially like when you're sort of the stuff on the software engineering side where they were trying to figure out a model to do a good like image-based search. And they were sort of like churning out like new models like every week, and then like every week like they would like compare two models with users and like bring back feedback to the engineer. So it's kind of like a more collaborative process of like model building and evaluation with users by involving UX people, which was at least like shown to be helpful in this organization. So in this way, like, in successful organizations, we observe like many such like leaky artifacts across like UX and engineering that they would share with each other. So on the UX side, like, to communicate like user needs for like training data, like UX does a lot of like qualitative coding, and like they develop code books and labels and categories. So they would share those things, or like templates for data formats, or like different personas, which would help in like representativeness of users. To communicate about like user needs for AI behaviors, like, they would share everything from like ground truth data to low fidelity prototypes to scenarios to reports, usage reports. And to communicate feedback, again, like video footage of the evaluation session, not just direct participation of engineers, notes. Similarly, on the flip side, like, the engineers like would share things like training data specifications, like labels in like JSON format, computational notebooks, which then the designer could like run some queries and like try to understand the data a little bit better, or annotations over wireframes as to like what's going on under the hood, raw model output, dashboards, demo prototypes, as well as like, parameter settings and feature weights. Like they would build these prototypes where like the designers would have like knobs to control certain parameters and like see how things changes and like what's actually like makes sense for the users. Yes, yeah. So when people have qualitative data, say from like interviews, you're trying to then build categories and themes out of it and like what people are saying. So the way they do that is like, there are many different coding techniques, but then like you determine what labels to use. And then like a code book is like a dictionary of like the labels and like what each label means, and it often contains an example. So think of like a way to like conceptualize like categories for some model you're trying to build, or like labels for some model you're trying to build, and then the UX people can actually go and like determine like what are the labels that make sense. So if maybe you're thinking about like different genre for like Spotify music or like YouTube videos, how do you know like what is a categorization that actually makes sense? Yes. Sentiment oh sure, like if you want to think of like a set of like sentiment categories, then sure, yeah. But it can be like any kind of labels. It's just like a human-centered way of thinking about like what labels make sense. So yes. Okay, will do.
If people want to ask a question, tell me, I'll give you a mic.
Awesome, thank you. Yeah. So just to summarize like this work, what we noticed is that these sort of like abstractions like provided teams an alternative to either like a UX first workflow or an AI first workflow, where like someone builds a model and goes to product teams and say like, hey, put this into this product. So, and what we notice is that like, in early design stages, it was helpful for like designers and engineers to start producing like these fuzzy specifications, which they would then share with each other. That's my animation. Which they would then share with each other, and then they would like collaboratively like assess and negotiate and sort of revise their design choices. So for instance, by sharing like, emerging AI behavior specifications, designers can evaluate assumptions and like fit for users, update their own design representations, and provide feedback for AI design. And during this design stage, like avoiding committing to specifications like made the design more pliable and invites collaboration and inputs. But then as the design progresses, like, more and more aspects of these like UX and AI components become more like concretized, and consequently the need for leakiness sort of reduces. And it's only in the final stages where like, the solutions are aligned across like AI, UX, and people. Yeah, so like a comment that captures this is like, I think the process that works best is a fairly tight review cycle with actual evolving behavioral artifacts. Okay, so based on this, like in my lab, we've been building a bunch of like tools to see how we can actually bring in like tools that allow for this like leakiness to, how to expose leakiness or like the information across like UX and AI. I have two systems here, but I think I'll only have time to present one. So we'll do this one. So we built this tool called Proto AI, and we built this workflow called model informed prototyping. So if you're a UX person, like, of course, you have like fancier tools like Figma, but then like in a sense, they all do something like this, where you can like put placeholders and labels and say, this is a text, this is an image and whatnot. But then like it's completely like sort of like abstracted away from like the underlying model or what information is actually going to go in there. And if you have to do that, like, there's the screenshot is from a while ago from like Runway ML, where they had like these model exploration tool. You'll have to go like elsewhere and like try to understand what this model is doing. And then you'll have to sort of like bring it back to like some other evaluation tool to understand like where this works. So we're trying to see like, but it makes sense for all of this to be integrated within the UX prototyping process. So we were trying to see like, how do we combine this like model exploration and UX evaluation, UX prototyping and evaluation all within the same workflow, and then we built this system called Proto AI and this workflow called model informed prototyping. So this is what the tool looks like. There are 4 tabs. There's a tab which has like a collection of like ML models and services. There's like a tab where you can actually like simulate the model with like real end user data and like see how it's performing. There's your UI prototyping tab, and then there's like this prototype evaluation tab. So just for demo purposes, like imagine you're building like a simple application to identify different bird species. Maybe you're interested in birds, and like every time you go out, like you pull out this app and you take a picture of the bird, and it'll tell you like, what bird it is. So to do this, like what you would do is you'll first go to like this, the first tab, which is the models tab, and you'll choose like this image classification model. And maybe you've talked to a bunch of like bird watchers or like bird enthusiasts, and like you've collected a bunch of their photos, and now you can bring those photos and import it into this tool, and then you can run the model, and you can see like how this model is performing for these different birds, and it'll give you like, a set of like confidence scores and a bunch of like three labels or so on. So over here, you can already start to look at like, how this model is functioning. Like, is it good enough, or like, do you need to pick a different model, especially like if you're using like off the shelf, like pre-trained models. And now you can go to your user interface prototyping tab. And I'm just adding a label. But the fun part is now you have these data elements. So which means instead of just putting like a placeholder image, you can actually take one of the data points from what you uploaded, and you can also add the label for that, with the label that the model returned over here. And then you can go to, sorry, this is like a bunch of videos, and I have to click play. And now when you go to the evaluation tab, you're going to see what the interface looks like for every single data point you uploaded in the second data tab. And what this allows you to do is then it also like, because you like, if you supplied like what the ground truth label is, you can see like, how many instances of errors exist. And something like this is necessary if you're going to build these sort of like mixed initiative interfaces that are dynamic and changing based on like, what the model performance is. So now what you do is like, okay, you want to know like which are the error instances, or like what is the confidence score or whatever, and you can bring that information and like add it to your interface as a sort of like annotation, and now you get to see these values as part of your interface prototype. And then over here, maybe you see like, any labels with like confidence values less than 60 usually tend to be incorrect. So now you can figure out like, how do you design interfaces to fix that? So what you might do is like, you might then go back to this tab, and then you'll add like a new conditional state where you say like, if the classification accuracy is less than some value, show this new interface layout or interface state. And maybe here you want to give them like a bunch of different options and allow them to enter their own option or whatever. There's like a state of the interface for like low accuracy. And then maybe you build something like this. And then And now when you go back to your evaluation, you'll actually see like, when there are instances with like low confidence code, like it shows this alternate interface. And there's a bunch of things you can do, like, if the model hasn't been built, like if you're trying to determine or like shape the behavior of like what the input output has to be, like you can do all of this on your own, like, and then you can hand this off to like the engineer. You can do like a bunch of like column transformations. So like, like in the Google Flight thing, it just shows you like low, medium, and high. And like, that's something that as a UX person, you can make these transformations and like make new columns and derived columns and like see how to visualize that information. So it sort of like expands the design space of like what UX prototyping entails. Like now you have this input data, like you have these model features and like outputs and ground truth and like derived data, and that allows you to like test out like different like facets of the interface, and you can sort of like augment or overlay things like explainability. I think I skipped one of the slides, but you can have like heat maps of like what things happen or whatever like explainability features that are sort of tailored towards like your UX design, like you can start to build them. And if we had tools like this, like, I don't know if you remember this from a while ago, where like Twitter would always like auto crop like pictures with like darker and lighter skinned people to always like have lighter skinned people. So if you had a tool like this, you could have tested this out with like many images and you would have caught this issue like upfront. Or it could be useful for like Netflix movie recommendations, where you can start to curate a table with like some initial preferences, and you can test it out like, across this like different users, like user personas, what this looks like. Or like, these mixed initiative ambiguity widgets, which I think this is from like Facebook, where like if you search for something and if it's uncertain, it'll ask you like, did you mean something? So this tool allows you to design for like errors and failures and ambiguity and uncertainty and so on. How much time do we?
Your choice.
Okay.
It's 15 after. You have 15 minutes if you want.
Okay. So, okay, what I'm going to do is I'm going to skip this tool. So we just built another tool that would allow, UX researchers to do their research and like figure out like what is the best model to use. But I'm happy to share the slides of the paper and you can look at it. But I think the stuff I want to maybe cover in the last few minutes is so what's going on with generative AI? Like everyone's all about generative AI today, and then like all of my industry colleagues are excited, but also stressed about like putting generative AI into all of their products. So very recently, in collaboration with Google, we conducted the study to understand like what it actually means to prototype generative AI applications, right? Like we're already seeing the shift when we go from like conventional software design to like the more traditional machine learning approaches, where like the role of like data becomes so essential and the kinds of collaboration that we do. But then like now, like everyone's working with these like large models, foundational models, and like people aren't actually building models on their own. So how does that shift this like software engineering landscape? Like what's happening with the roles of like UX or engineers or product managers? So essentially, like if we go back to our like flight booking example, like this is what your new flight booking interface might look like, where you're engaging in a conversation with some agent, a chatbot, to sort of try and book your flight. So then what's going on here? Like how are we building these applications? So to do this, we conducted a bunch of these collaborative prototyping sessions with about 39 participants across like India and the United States in 13 sessions. Each session had like a product manager, a UX designer, as well as an AI engineer. Together, yeah. Like we had like, we wanted to understand like how are each of these roles contributing, like how are they working together? And like, each of these sessions lasted about 2 hours. We gave them a very simple like design activity. We told them like, imagine you're building a new generative AI tool for a marketing content creator. So like, to help them augment their marketing content creation process, and like they have their own clients and whatnot. So we wanted to understand like how are they imagining like building an application like this. So in terms of findings, like one of the biggest things we found is like, like I mentioned earlier, like in Proto AI, like a lot of us like data centric. And now like this like complete shift to everything being like content-centric prototyping, where you take in like this ideal golden state, like desired content, and then you try to like determine like what prompts might produce content like that. So just very briefly, like, based on what we observed in that session, like these prompt prototyping consists of like at least 4 distinct types of things that they need to prototype for. One is like the input context, like what is the thing that you actually want your end users to provide. And then you have like your base prompt or system instructions, and you need to think about like how do you sort of craft those things. And then like you may want to give like few short examples, as well as like constraints to output to these models. So like at least like based on the sessions we observed, like these are the things people were talking about or like trying to prototype. And again, like this, oops. So again, like, the desired content, where like what we noticed is like across all these sessions, like people would just go and like Google or like search for like, different like advertisements and things like that, and like bring that content into their prototyping workflow, which we thought was like really interesting. But then there's obviously, a lot of like legal and like copyright infringement issues that needs to be considered. But most central to the point is like, this is sort of like a workflow that we saw like people followed in this like content-centric prototyping, where you have this example desired content, and then like you may have some layer of generative AI user interfaces that are sort of like backed by a bunch of like different prompts to do different functions. So what you would do is you would take this like example content as starting point, and then like start to create like prompts. So like, if you saw like a really short advertisement for like a body wash, and then you would go write a base prompt, like, this thing should be like really short. It should be like enthusiastic, or like it should have like exclamation points at the end or whatnot. So they would start to like build prompts by sort of like analyzing and deconstructing and extracting attributes from like these example content. And then like when you're starting to evaluate, like, oh, is the model trying to produce like, does this prompt allow us to produce this kind of output? Then like this example content sort of like serves as like benchmark to see like, oh, is this the kind of content I want? And then also like, across like many such example content, then you start to think about like generalization, like can like, a marketing content creator like use this tool, use these sets of prompts to create any kind of content they want. So it's just sort of like this high level overview of like, and then they would sort of like tweak, like, like many of these models have like a temperature thing, they would tweak that and like see like what's happening. And then like it would be this iteration of like authoring a prompt, like testing, like seeing if it actually produces the output, and then like trying it out like multiple times, and then like analyzing the generated content to then like see how you should like further tweak the prompt. And in terms of like the specific prototyping strategies itself, interestingly, like, across 13 sessions, like we noticed people took many different approaches to like prototyping their prompts. You had like some sessions which would start with like, imagine you're a marketing content expert, and like, they would start off by assigning like these agent roles, and then they would then like give them the knowledge and attribute to these agents to start producing the kind of content you want. A second approach was like, I'm just going to like write something like simple, like, write an Instagram ad for an energy drink, and like look at what kind of output it produces, and then like start iterating based on that to add more constraints and add more details and flesh it out. In other cases, like they were thinking about like a prompt template, like, oh, like, what are the things we want people to input, and like how should these base prompts sort of like operate and interpret those inputs that the users are providing, and they would try to like define like a prompt template. A fourth example is like, as I mentioned earlier, like you start with an example content and then like try to extract like what a prompt should be that might produce that kind of content. And the last is again, like, a few short examples where instead of worrying about like crafting like a well-defined detailed prompt, like they would just give like a bunch of examples and like hope that the model would infer like what the kind of content it needs to produce. Yeah, so like this iteration is guided by AI generated content rather than like, some like UI or backend logic. And a lot of this refinement happens through like these desired example content, and then to see how the prompts that produce output that aligned with those outcomes. There are some challenges we noticed with doing something like this. Some of these are like challenges more generally with generative AI models. It's most of us don't know how these models work. So as you're iterating on it, like you don't have like good system mental models of like how these inputs correspond to different outputs. So it's really difficult for teams as they're prototyping to figure out like what tweaks in the prompts can consistently produce the kind of output you want, right? Like, so in this case, like there's like one of the participants was like, write a persuasive ad highlighting the benefits of anti-aging cream. And they were trying really hard to figure out like, why did this output have like the age, reverse your age by 20 years instantly? Like they just couldn't figure out like how to not get the model to ever do that again. And there were like many such instances, right? Like where people, there was like this other thing where they were like, write like this marketing ad for like an energy drink for like the youth or something. And like the model would just introduce like this new competition for something when no such competition existed. And like, how do you start like adding in your base from like, don't ever introduce a competition or don't ever talk about like how many years, like that doesn't really make sense. And I think this is sort of like one of the big challenges with like trying to build these models that are a little bit more like controllable, and which is why like people start adding all these like guardrails. And I was just telling Ted on the car ride here where teachers, right, like I'm in education, I work with teachers, they try out like, can a student write an essay about chocolate using ChatGPT? Yes, they can. Can a student write an essay about like, the Black Panther Party and 10 points? No, they can't, because there's a bunch of guardrails against like producing content like that. And this is sort of like stuff that people miss out on when you don't have like good approaches to like consistently get the kind of outputs you want. And the second thing is like navigating like some of these assumptions and stereotypes. Like, we are humans crafting these prompts. We make a lot of assumptions as to like what goes into the base prompts. So there was like this one team that was that used like a Tesla car example as a model inspiration for this thing. So the base prompt contained a lot of like gender specific information. So the outputs that they produced were like consistent with that kind of language. And you and I, as end users of these products, like, we don't see what the base prompt is. And like, there's this lack of transparency, and like, you don't understand, like, why is this model producing this thing? So a lot of these assumptions that get baked into these base prompts, like, we need to figure out like better ways to like first assess and validate, like, are those generalizable, but also like, how do you expose that information to end users of your tools? And the last thing is, again, like as a consequence of doing this sort of content-centric prototyping, like we tend to like overfit the specific examples. So people like, when they start, like you start to see like no matter what input you give, like you start to see like similar kinds of outputs, right? Like packed with innovative features, like packed with world-class equipment. So like the other danger is like using the specific examples for guidance, like leads to like overfitting of the kind of outputs you get. And which is also like why we start to see that a lot of things start sounding same, and more like people use generative AI. Like a lot of papers read the same, a lot of student assignments read the same. Yeah, so those are some of the challenges. Again, like this is like a very preliminary study. A lot of the current work is focused more on like how do we build better interactions to align people with models in real time. So some of that is like ongoing work in my lab. So to summarize, right, like, there's been this shift from like conventional software to like traditional ML to generative AI. And that's also changing these different roles and expertise and boundaries and tools and artifacts that we're producing in sort of like interesting ways. And we should like, especially if you're in the industry, like you should think about like, is this model still working, right? Like these teams that exist today are a reflection of like the kind of software we used to write many years ago. So essentially like, so in summary, like these are 3 points that I think might be interesting to think about. Like the first is this merging of roles and responsibilities of sort of like obscured like individual agency and ownership, and sort of like challenging some of the conventional like division of labor or like separation of concerns. So we're going from like rigid separation to fluid collaboration. The second is like, again, like, these sort of AI capabilities are no longer fixed. They're evolving dynamically through interactions. So UX design must explore and iterate this behavior in real time and shaping this boundary between like human intents and AI responses. And the last point is like, UX is moving beyond like designing interfaces to architecting like intelligence. Or like these adaptive intelligence. So then like, how do we make these invisible like AI boundaries like visible to both people in like software teams across different roles, but also like to end users. So these are some open questions. Thank you for listening. And
you're gonna have to tell us when to shut it down, because if you start falling asleep, we'll know it's over. But I have to say, the concern is, I think this leaky approach probably always was needed for all engineering tools, and I just want you to respond to that. But I don't mean to take it off track.
Yeah.
Hand this to somebody else.
Yeah, I think so. I mean, like, initially, like back in the day, like, if you've read this book on like bootstrapping, which is about like Doug Engelbart and like, the real user and the virtual users, like it was a lot of like, the engineers like assuming the role of users and making decisions, and turns out that was not optimal. And I think a part of it is like, it's very difficult for most of us to like acquire expertise across these different disciplines. So then like people, enrolled in like HCI programs, people enrolled in computer science programs, and like, and of course, like, any organization is like interested in like optimizing for efficiency. So that's just how it happened, where like fewer interactions, the more you can like hand off things to each other, like the better, more productive, more efficient. So it's sort of like how, like, I agree with you, like, I keep sort of like, I tell this a lot, like if I could be all these multiple roles in one, like it would make my life so much easier. Yeah.
Thank you so much. My name is Margaret Irvin.
I'm not sure why. It's the same mic, right?
Can you hear me?
I can hear you.
I'm happy to like relay the question. Yeah.
Okay. But the first thing you'll have to do is that at some point you don't have to have background about whether it's easier for designers to learn engineering or engineers to learn design concepts. But we'll leave that for another day. I wanted to go back to your qualitative code book, because that also caught my eye.
Yeah.
Because it actually sounds as though what that is a model for content strategy that informs both the modeling from a technical perspective and from a design perspective. And it kind of says that about the leaky abstract and having to use it all along. And it's not that needed to be perfect.
Yeah. So the gist of the question is about like this qualitative code book, and like, is that an example of like why like the abstractions were needed all along? So the way I would respond to that is like, so, in sort of like the more conventional software development, engineering teams weren't trying to like acquire or use this information of like labels and categories and whatnot. So like they're going by like the human-centered approach. Like you had people who knew how to like talk to users and how to like sort of like elicit like what are like these categories that might be useful to people, and then like you would then like build systems, right? Like, if you think about like file systems and different file types, like, someone actually went and like found out like what different file types we need or whatever it is. But now like there is this like independent need for like the ML people, like, they want to build models, they want to label data so that they can train models. So there's this like need that's independent of like UX. And although like, it should be that like the labels you choose to use are like the ones that actually like reflects like end users' needs and values and so on. There's a lot of cost in that. Like you should also like, building like ML like model development like happens again in iteration. So in many of the people we talk to, they would just go to people sitting around them and collect data from them and label that, train the model, see if it works. If it works, then they would expand to other teams in the space in the office. And it's only at some later stage that they would actually go and either hire some organization to collect data, get them to label data. And I think the particular example of the code book and we could be talking about health or elephants in a circus was related to being able to classify medical documents. So there was this organization that brought in a bunch of clinicians or doctors to annotate the label. And there was this UX designer who also had a health background. And they were I should be in these sessions. And they noticed inconsistencies, right? Multiple doctors label things differently. So they were I could have done this job better. I could have produced a code book by talking to these doctors, and then that could have produced consistent annotations with data. I don't know if that answered your question, but hopefully it gives you a little bit of context.
Hello. Yes, awesome. Yeah, thanks. Maybe you could expand just a little bit. I'd love to hear your thoughts on that qualitative code book being an abstraction of content strategy and content design.
Yeah. So when we are training models, a lot of times we encounter inconsistencies in data and label, and we're okay with it for the most part. And I think, yeah, the point that this person was trying to make was how do we then streamline this process or make sure we have consistent labels so that we don't encounter these issues downstream of having sort of lower accuracy or whatever. So that was the context in which this code book, which is a practice that is so central to UX research and UX design, could have actually helped produce better training data and annotations.
We have a couple of questions from the chat.
Awesome.
Godwin Prabhakar, would you like to unmute and ask your question?
Yeah. So hi, Hari. It was a wonderful presentation. Am I audible?
Yes.
Sorry. Yeah. So my question was, what can actually give more confidence in a product idea to take it forward when we don't have much resources, like in an academia setup, only we have few people either in UX side or the development side, let's say AI. So should we go tech or AI first approach to validate if the backend is even feasible? Let's say because we might not even be training the models or fine-tuning the models, but rather use the existing LLMs that are available for the systems that we develop. So should we even go for validating if those models can actually help the intended use case that I'm actually building on? Or should we go the experience first, the UX design approach first to figure out with the user journey if such a need or thing is even as such a requirement is even there for an AI to actually we actually try. Yeah.
Okay.
We try to do
Thanks for
parallel.
that question.
Yeah.
Okay.
Oh, yeah.
Let me think about it for a minute. That was a long and interesting question. So you're talking about in academic settings, the couple of things you mentioned. Maybe I'll start off with this notion of working with pre-trained models.
Yeah.
I don't think an AI first or UX first approach. So the other thing is these models are so fragile. They're we were working we have the system called Spellburst, where we built this tool to support generative AI artists create artwork using natural language and Gen AI. So we were using GPT 3.5, and we went and collected a bunch of data to fine tune this model, and then GPT-4 came out, and then the model performed better without the fine tuned data. And so like, and it actually performed worse when we actually gave it like some of the when we did fine tuning. So, and I think like, you know, the sum of it is like still unknown, and like how do we work with like these large pre-trained foundation models, and like, you know, when will it work, and like, you know, and what sort of instances it's not going to work. But your other question of this UX first approach, right? Like we're noticing this in at least in like academia. Like everyone is like excited about using generative AI, but then like the motivation is like not compelling or like severely lacking. Like there's for some reason like, oh, people don't like writing text messages, so I'm going to use generative AI to create text messages. I think the most recent thing I heard is like there's this a person in like healthcare. They were like, oh, we're using generative AI in healthcare, and like it's this cool thing. And I was like, okay, what are you using it for? And they were like, we're using it to generate like messages for loved ones in like these like gift cards or greeting cards. I was like, isn't that like the one thing you want like a person to write to another person? Like, why would you use generative AI to create that? So I think like, you know, right now, like there's obviously like, you know, everyone is like excited, in some cases like even incentivized to use generative AI because that's where a lot of the funding is. But then like you need to really think about like, is this something that actually needs generative AI, or is a more traditional ML model like better, or is like no model better? And I think that I don't know if this answers your question, but that's how I would think about it, especially in academia, because we're also like, you know, trying to push the field and like think about like where like HCI is going. And I feel like as a field, like HCI is experiencing a little bit of like existential crisis. So we'll well, computer science as well. Yeah.
Unlike journalism.
Unlike journalism. Go talk to those people at New York Times. Yeah.
This is Edwin. I just have a question about the example you were going through, the prototyping tool with the tab that was about showing examples in the in the learning, in the algorithm, and various. So one of the points that you made there was that one of the benefits of having that tab and that sort of like model instantiation available is that it shows you potentially more of the design space, or more of the space that's available or necessary to design for. Specifically, we focused on the degree of confidence there. And I would venture to suggest that at least on that, you know, dimension, that's sort of a predictable thing that as a designer we would be thinking about anyway. What's the degree? To what degree is this an error? To what degree is there uncertainty? And those are potential use cases we would already design for. Is the argument then that the model is such a black box that it could produce stuff along dimensions that we could not predict? And therefore, and that's the black box essentially creating or illustrating a bigger design space than we might otherwise anticipate?
I think that is right, in the sense that when you don't like have, there's a bunch of things you can do with that specific like section of the interface, right? Like everything you're doing on that layout is on that screen, on that table, is essentially API design. So you're getting access to like the different sort of like outputs the model is able to produce. But then you can also start to define like the kinds of things it has to produce and what format it has to produce. Like essentially, like you're trying, like, you know, one that specific view is useful for designing these model APIs. But also when you don't have access to, like, you know, a couple of things, right? Like it can be useful for like model selection if you have like a bunch of pre-trained models, right? Like if you look at like Hugging Face of like, you know, 100 different models for any task you want to do. And then like once you have this data, then you can you like start comparing these models, which is part of what the failure notes thing does in a little bit more detail. But then like imagine there's no model for the kind of thing you want to do. but then you can like curate like the inputs and outputs and what format you want things to be, and you can build the experience independent of like this backing model, because then you're using information in the table, and then like once you have things working, you can hand off the table to like the engineering team, who can then like start to build based on like these specifications. So now you're not just specifying the interface, but you're also specifying, you know, the model behavior to some extent.
So thank you. Alps, you have a question? The question from Alp, do you want to unmute and ask?
Yeah, great presentation, thank you. So my question is, how can we possibly integrate cognitive modeling into this collaborative process and overall the whole entire design and development? Because with AI, especially if we train it properly, potentially it would be possible to do this. And I was wondering if you looked into it.
Would you mind elaborating a little bit on like what you mean by cognitive modeling?
So this basically, in simple terms, replicating user behavior based on other studies, and how some of the use models probably worked in the interaction, particularly in interaction design.
Let me think about it. So are you referring to like using like past behavior data to then model like the interaction space?
Yeah, I mean, you know, some of it goes to pragmatic you know, results and data sets, but some of it also goes to how human cognition functions, you know, based on known knowledge, and being able to model that and then run it through, so that you know, this would be, you know, a very sort of naive example of that would be putting Siri against you know, Amazon Alexa, and have them have a conversation, right? So imagine that type of you know, interaction being performed with modeling, and then run it against the designs that being used in developing AI experiences.
I'm sure, like I know of like colleagues who are doing that and like using like user modeling techniques to then like determine like what is the best interface option and all of that, like through a more computational approach. It doesn't necessarily relate to this, like you know, maybe in a way like you're sort of like using data to determine like some specific like interaction behavior or interface choices. And I think like, you know, there's a lot of work going on in there, especially some of my colleagues at Aalto University are doing this work.
Yeah, the reason I brought
I don't have like anything specific to add in terms of like this collaboration and the kind of like computational modeling or like user modeling you're talking about.
One of the things I think of in that question is, you know, historically, AI people did modeling.
Yeah.
Yeah. And so we build the model by rough paper now, as opposed to by having some conceptual framework. And I think that, you know, of course, both are important.
Yeah. I think like also like, you know, all of the cognitive modeling or like the computational models that we see of like human behavior are like, at least like today, like limited to like interaction patterns, right? Like we don't really have good ways of like capturing what's going on in people's head. And I think like like even like eliciting like simple like mental models of people is like really challenging. So I think we'll have to like bridge that space if we're going to actually think about like then using like, you know, there are like abstract cognitive models, like, you know, in psychology you have like cognitive models of how people read, like how people communicate, how people formulate tasks and all that, right? Like, and this is all like the more the mental model kind of work that's happened in HCI. Yeah.
But there's another point, which is the way that these different approaches break down is different.
Yeah.
So you can generalize with cognitive models.
Yeah.
Of course, the fact that they aren't perfect make them break in certain ways. And you can, and we make fun of the hallucinations, the 20-year thing you're talking about. But those are ways that these break down. And one of the things that maybe people like about cognitive models is that it's more explainable. And yet we're busying ourselves figuring out what exactly we can do with our prompts to make these more reliable, which is what we're focusing on at the moment. So I don't know if that helps.
I mean, like, it helps with like certain specific like interface interaction choices, but I think like these complex like intelligent partnerships with an AI, like I don't think we're there yet. Sorry, I'm not sure I answered your question, but I'm happy to.
I understand. No, I just wanted to get your perspective, because one of the things that I think it would be really useful.
Which is very interesting, and then it leads to a question. One is that when a technology is new, I'm thinking of Google search, early days. It was a very successful product. For many, many years, developing quality. It was a very data-driven product in a lot of ways. Right? You could imagine a world where early on you might try to design a lot of things in ineffective ways in web search. Well, Google came up with a process of human evals as well as automated evals, and a data loop involving when users click on the content, and that led to sort of like a flywheel for very, very high quality. I think of that a lot in data-driven product design now, because it seems like many of the things that are now suddenly possible with AI, it's almost like products that used to be designed by hand are now data-driven. And so it seems like your talk made me think of that. That's what if you think that might be the case, maybe your last slide is even going further than your last slide and simply say that there's a whole set of category of products that are going to be driven by the data and designing data loops around them, instead of in the sort of traditional way of like, let's think what the user needs and then map it out, which is true for certain things. But not maybe for a larger category of products. That's not the case. I was wondering, thought of it that way.
That's sort of an interesting way to think about it, right? Like the way any like search results or like generations are like sort of data driven. I agree with you, like, that's been like incredibly helpful in like shaping what like search experiences have been. But then like, if you think about it from like an information standpoint, like it's also a little bit like problematic, right? Like where it sort of like constrains, like just as a consequence of like this being data driven, like it also like constrains the bandwidth of information you get exposed to, because like everyone like gets the same like top 10 like search results. And then with generative AI now, like it again sort of like generates responses at the center of some distribution. So I think those are some problems where you don't get like, before like Google search and before generative AI, like if you needed some information, like you would go to maybe a local like town library, you'll ask people, and like the information was a little bit more authentic. You had like a broader bandwidth for like acquiring information and knowledge. And then with search, like it started narrowing down. And then like with generative AI, like now there's this like whole like knowledge centrality, knowledge collapse.
Very powerful is Microsoft Excel. Right? And it's a different challenge, which is that a lot of the use of Excel is only because there's experts who build very complex systems in Excel in order for Excel to be the highly reliable product it is. And again, I don't think we quite have the Google search data loop or the Microsoft Excel product. So we're trying to it feels like
it is hard. And I think like, a lot of these like application experiences that we're building, and I think like Ted brought up an example, I'm forgetting a specific example, but where a lot of the ways we're imagining generative AI will solve things for people, like experts don't like it. I think like it's more work for them to like take what like an AI produces and get it to what they want, than like based on their own like expert knowledge. Like there's a little bit of challenge of like controllability as well, but then like like, you know, you're trading off like fast generation for you're trading off expressiveness for like faster generation. And I think that's a problem that experts don't like. And this has been like a problem for a while, right? Like even like the more traditional like AI things and like building like creativity tools, like, yes, it sort of like raises the floor for like an average person to be more creative. You can use like DALL-E and like make sort of like cool images. But then like if you're an expert, like, so I don't know if you know, like it was last year or the year before, like this AI generated art won like this prize in like the Colorado State Art Fair. It took the artist over like 99 prompts or iterations to generate that image. And most of us are not going to sit and prompt DALL-E like for over like 99 iterations to get the kind of things we want, and like we don't care. But then like these experts care, and so like, you know, is it more worthwhile for an expert to spend like prompting an LLM like close to 100 times, or is it better for them to like figure out, like, you know, there's probably some middle ground, but then like, you know, having like sort of like expressiveness and like controllability is really important, especially if you're an expert and you have like these specific techniques and skills and knowledge which you want to use. And which is why, like, you know, we're starting to see like, you know, more and more systems that sort of like combine like neurosymbolic approaches, right? Like symbolic AI with like neural AI to sort of reach some kind of a middle ground.
So people are good at what they're good at. And
yeah.
To talk to oneself than to have to interact with another. And I guess when we talk about interacting with another, I kind of think that a lot of what we're doing is kind of an anthropological exploration when we're discovering what is known through the generative AI interfaces. And maybe we will learn that the way to work with these tools is think of it as an anthropological exploration rather than pretending that it is the driver. And it's going to do it for us.
Yeah. So like if you're interested in like this topic, especially generative AI, like we have a paper at CHI in 2024 called like Cognitive Challenges in Prompt-Based Interactions with LLMs. I encourage you to check it out, right? Like we identify a bunch of gaps with like just being able to prompt an LLM to do what you want. And, you know, starting off at like, you know, the traditional like Norman model of like gulf of execution and evaluation, and like what changes, right? Like you no longer have like system mental models, and you don't have good user interfaces that'll help you like plan your goals and intentions, because like, you know, LLMs understand natural language, so you can just talk to it and like say anything you want and try and get the outputs you want. But then like there are a bunch of gaps, right? Like there's this, we identified like 3 gaps in that paper. Like one is the capability gap, where say you wanna like, you're writing like a retirement toast or something and you want to make it more humorous. There are like many capabilities of an LLM to use. You can ask it to add a joke to it. You can ask it to like rephrase it to make it a little bit more funny. So how do you know like what is a capability that you want to use when you don't have like interface buttons where you can click? And then once you get past that, like, you know, how do you instruct it to like, you sort of like in a way that will give you the kind of output you want? Because like these models are like so sensitive to linguistic variations, and like, you know, say something humorous versus like write a joke versus make it funny might give you like very different responses. So how do you know like what is the best way to prompt it? And then with a lot of these generative tasks, like, you know, generative tasks like cognitively, like generative tasks take this approach of like planning, execution, evaluation. And then like with generative AI, like you're doing a little bit of planning, you're foregoing execution for the LLM to do the execution, and then you're trying to evaluate. So when you're not involved in the entire process, you don't have good internal cognitive benchmarks of like, is this the best output? Can it give you, or like, can you do something to get a better output? So these are some of like the initial challenges we've identified with sort of like these prompt-based interactions with LLMs. And, you know, thinking through some of this, and like as an HCI problem, how do we solve these things, like these gaps? We call it the gulf of envisioning.
Gulf of envisioning, I guess I'm envisioning that it's getting late and you've been up since, I believe, 3 a.m. You told me. So I did notice that there's somebody that wants one last lick at you, or maybe not. And I also want to keep putting on their jackets. So with that, I guess I want to just appreciate everybody coming here and enjoying the space that Pete Lynn worked so hard to build. And thank you, Pete, for being here and letting us in and letting us use this space. We love being here. And, you know, if anybody wants us to think about having these talks earlier, because so we won't be getting people to stay up so late, you can come to the steering committee next month. But with that, I want to thank Kari very much. That was a fantastic, energetic experience. And thank you very much for everybody coming. And we'll see you next month.
Yeah, thank you for having me, and like, thank you for staying so late.